So welcome back to part 2 of this video, and we're going to go ahead and talk about how to write formulas and how to name covalent compounds. And good news is it's way, way, way easier than ionic compounds. Bad news is it may cause some confusion, flip-flopping between the two, because they have very, very, very strong similarities, but they also have quite a few differences, significant differences. So let's start at the top. Let's talk about naming compounds. Naming compounds is really, really easy for covalent because all you're going to do is give the name of the first element, straight up, nothing different. For the second element, just like you did in ionics, you're going to use the name with the IDE, like oxide, nitride, phosphide. And then, this is the easy part, you're going to use prefixes to indicate how many of each atom is present. For instance, mono is the prefix for 1. We don't tend to use it for the first element in a formula, but we do always use it for the latter ones. And the other weird rule is when you do add that prefix, which we'll talk about the prefix on the next slide, to your list, if you have two non-I vowels in between the prefix and the name of the element, then you're going to drop the first one. And we'll show a couple examples of these. So here are the prefixes. If you have 1 of something, you say mono. 2 of something, it's di. 3 of something, it's tri, like tricycle. Here's the one that trips most people up. 4 of something is tetra. I always remember it because that old school game Tetris, all the symbols, all the shapes had 4 blocks. So that's where the name tetra came from in Tetris. 4. The rest are very much based on your geometry. 5 is penta, 6 is hexa, 7 is hepta, like hectagon, heptagon. 8 is octa, 9 is nona, and 10 is deca. So the only ones that are kind of weird is mono, di, tri, and tetra. And even di and tri aren't that hard. So let's see how this works. So if I had these compounds, pH3, and I had to name it, that would be phosphorus trihydride, meaning I have phosphorus. There's 1 of them. I wouldn't say monophosphorus, but that's phosphorus trihydride. Phosphorus, the first element. No mono out front because you don't put a mono out front. Then the second element is hydrogen, which becomes hydride. And you put the prefix in front of the hydride saying there are 3 of them. Trihydride. How about the next one? CO. This is your first element is carbon. And since there's 1 of them, we don't put the word mono out front. The second element is oxygen, but oxygen, because it's the second element, becomes oxide. So that becomes carbon oxide. But wait, the second element, if it has just 1 of them, we do put the mono in front. So that becomes carbon monoxide. But what did we say about the 2 vowels? If there's 2 vowels next to one another, when you put them together, you drop the first one. So we're going to drop the first O, and it just simply becomes carbon monoxide. The next one, we have nitrogen. And there's 2 of them. So I would say dinitrogen. And then we have oxygen, which we're going to use the IDE suffix. Oxide, we have 3 of them, so 3 oxides or trioxide. So this just becomes dinitrogen trioxide. Last one, nitrogen and iodine. So nitrogen, there's 1 of them, so we don't put a mono in the first element. So it'd be just nitrogen. The second element is iodine, which we don't use iodine. We would use the prefix iodide, and that would be, there's 3 of them, so it'd be triiodide. And yes, even though this sounds way more clunky than monoxide, triiodide does have the 2 I's in the middle, and you keep both I's. Because the rule was 2 non-I vowels. Actually, it's just going to be an A with an O or an O with an O, because the only non-metals that have vowels to begin with is iodide and oxide. Okay, so naming them, super easy. element name with a prefix, element name with the ID on the end with a prefix, with the two weird exceptions. You don't put mono in the first element, and you drop the first vowel of two non-I vowels. Okay. What about writing formulas? Again, simple. If I had to write the formula for sulfur trioxide, I would simply look at it very, very, very straightforward as saying I have sulfur S. I don't have a number, so I have one of them. I have oxide. That's an oxygen. And how many oxygens do I have? I have 3. There's your formula for sulfur trioxide. Super, super simple. Phosphorus tetrachloride. So phosphorus, P, diphosphorus, that means there are 2 of them. Chloride, that means chlorine. Tetra means there are 4 of them. The formula for diphosphorus tetrachloride is P2Cl4. Last one. Oxygen is oxygen. There's no prefix, so it means there's 1 of them. Difluoride, fluoride is fluorine, the element fluorine. Di means there's 2 of them. And that's the formula for oxygen difluoride. Very, 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 very simple. I think the drawback is you will start seeing these examples more frequently, and you will start accidentally using the prefixes. I always use the example that I often see someone try to name this compound BaCl2, which you did already know that this is just simply barium. It doesn't need a Roman numeral. Chloride. And before this lesson, you would have done that. But now what happens is we have a tendency of messing this up and calling it barium dichloride. And that's wrong. You don't put the di when you have an ionic. So when you have an ionic compound, no prefixes. When you have a covalent compound, prefixes. You'll always have a prefix when you have a covalent compound, because the second element does not have a prefix. It always has a prefix. Okay, so that's all there is to writing formulas and writing names. Super, super simple. Almost too simple, simple enough to make mistakes. So at this point, the last 2 homeworks as part of the packet was, one was naming formulas, writing for covalent compounds only, entire sheet of one side naming, the other side writing formulas, and then let's mix it up. The last handout in that packet looks at naming, and the naming and writing formulas, meaning taking and naming and or formula writing, but deciding whether or not the compound is ionic or covalent. That wasn't a very gracious transition. I forgot one thing as part of this lesson. So the last thing I said was we're doing the naming and formula writing for mixed, and I want to know, how do you know which one's which? So if I go to this, I look at, if I need to go do a comparison to ionic and covalent, what am I looking for? Well, the first thing I know that's different about them is ionic compounds consist of electrons being transferred, and covalent compounds consist of electrons being shared. You really can't tell that by the formula, but you know that's what happens. Second, here's one way you can tell. If you have the formula and it starts with a metal or NH4, which is ammonium, then you know this is a ionic compound. If you have metal and a nonmetal, or a metal and a polyatomic, or the NH4 and a metal, nonmetal, blah, 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 the metal's what you're looking for, or more than 2 atoms, you're going to have a ionic compound, which means you got to do Roman numerals maybe. You have to don't use the prefixes and all that stuff. Covalent, you're going to be looking mostly at things that are just two nonmetals. So both the first element and the second element are both nonmetals. You've got yourself a covalent compound. So looking at the formula, if you're given the formula, if it starts with the metal, and we know where the metals are on the periodic table, or it starts with NH4, ammonium, you know you have an ionic compound. If it starts with any nonmetal except for nitrogen tetrahydride or the ammonium ion, then you know you have a covalent compound. Covalent compounds get prefixes, ionic compounds do not. When writing a ionic compound, this is very, very important. When writing an ionic compound, I did it through the entire ionic compound writing section. If you write the formula for a ionic compound, the formula must have a charge. What do I mean? Let's go down here. Where's my mouse? There. So if I wanted to write the formula for, let's say, barium chloride, which I showed you on the previous slide, barium chloride, that's not enough. Since it's ionic, it'd be barium plus 2, need to have a charge, chlorine minus 1. The ions need to have charges on them if you're writing the formula for an ionic compound. But if you had a covalent compound, say phosphorus trioxide, and we know it's a covalent compound because it starts with a non-metal, then I know that this would have no charges. So must write charges on formulas for ionics, must not write charges on elements in a covalent compound. If you're looking at the name, ionic compounds will not have prefixes. There's a couple weird exceptions because some of the polyatomic ions have di in them. For instance, if I look at the table now here, I have dichromate and disulfate. That's the names of the ions. So they have the di in it, but you're going to have no prefixes per se in an ionic compound. But everything, there's going to have at least one prefix. Always the second element has a prefix on it, so you're looking for prefixes. That's how you can tell which one you have. Look at the compound, the formula. Look at the formula. Does it start with a metal or NH4? Ionic. Does it start with a non-metal that's not NH4? It's covalent. Look at the formulas. Look at the name. Does the name have a prefix? No, it's ionic. Does the name have a prefix? Yes. Be a little cautious of the disulfate and the diphosphate, dichromate and disulfate. Be careful, but for the most part, if it has a prefix, it's going to be covalent, which means no charges, and you just count the number based on the prefixes. That's it. So I just want to throw that in there at the end, just a quick comparison so that when you do that last handout of the homework, go backwards, do the last homework, the mixed naming and writing formulas mixed, your first thing you need to do is figure out whether it's ionic or covalent. Okay, that's it for lesson 4. Hopefully you get something out of this and you can understand a little bit better about covalent compounds. Lesson 5 is all about molecular geometry and polarity. I'll see you